Hello and welcome to the Daily Space for today, March 1st, 2019. My name is Dr. Pamela Gay, and I am here to put science in your brains. Today we're going to have a quick broadcast. I have some phone calls I need to catch up on, and we're going to be here late into the night tonight. So hopefully we'll make it up to you then. Tonight we have the test launch of the human-capable SpaceX Dragon vehicle. So we are going to watch a Falcon 9 do its thing, take off, hopefully land its first stage, in this case out to sea on I Still Love You, and hopefully we will see a whole bunch of cargo and one chair, one spacesuit, and one fake human being all make it up to the International Space Station. So tune in tonight. We are going to be starting roughly 2 hours before launch. That would be midnight Central Time here in the United States. So doing math. Sorry, I have to look at my screen to be able to do math. So our coverage will be starting at 1 a.m. Eastern, midnight Central, 11 p.m. Mountain, 10 p.m. Pacific time tonight. That is 5 a.m. UTC. So we will start with an hour of random happiness video game play. I will be your host. Astroneer does not work on a Mac, so I'm still sorting what games will be played. And then we will be going into launch coverage live 1 hour prior to launch. That is at 2 a.m. Eastern, 11 p.m. Pacific, and we will have a game of launch bingo. So join me for fun games discussion and essentially a middle of the night watch party as we watch the launch of this human-capable vehicle. Now, in today's news, we do have news to bring you. Our first coverage comes to us from the University of California at Berkeley. In this particular news story, scientists have been long trying to figure out how solar systems like ours end up with planets, asteroids, and other objects all cattywampus and how they're aligned across the solar system. When we first start looking at the planets, we see things are pretty much lined up in a plane. And that is as it should be for a spiraling flat disk of material that is forming a star system. Now, the problem is somehow some of the objects ended up, forming a spheroid around us. They ended up, doing all sorts of things that didn't leave them in that flat disk of material and instead left them in tilted orbits all askew in all different directions. And this includes objects like the theorized Planet 9 that we talked about yesterday, and so many of the other oddly elliptical, weirdly tilted orbits of the Kuiper Belt objects. Now, one possible explanation that works for explaining how you end up with objects like this is a close encounter of the stellar kind. Our star, like, all stars that we know of, formed in a cluster. It formed in a star-forming nebula that went on to evolve into an open cluster that went on to shred itself apart as all the different stars orbited around our Milky Way at a slightly different rate. Today we can't see what were the stars that we formed with any clear certainty. We see stars that have the same chemical signature as our sun, and we believe we probably formed with those stars. But it's not like we can just look around and say, you are moving like me. You, of course, are my open star cluster sibling. Well, in trying to figure out what star is to blame for our crazy orientated system, we just can't get there from here. So what we've decided to do instead, or rather what scientists working from the University of California at Berkeley decided to do instead, is to look for other systems that show signs of these, well, stellar interactions that had the potential to change the orbits of planets in the system. Here we see an image that was taken that depicts exactly, well, what that kind of a system would look like. These images were taken with the Gemini Planet Imager on the Gemini telescope in Chile. And what we see here is the binary star system HD 106906 that has a planet that is oddly far from its two, well, host stars. But it appears to still be on an orbit that keeps it bound up with those stars. Now, when you have a planet and you have two stars, there are a myriad of ways to fling that planet outwards. What is harder is flinging it outwards in such a way that it lands in a stable orbit, which this planet appears to have. You can explain this kind of a setup, however, by looking around for stars, in this case, these two over here, that would have flown past that binary system in the past and gravitationally given that planet a nudge, changing its orbit just enough that it is stably located in that star system. So here we are with HD 106906, and it looks like we now have that clear evidence that, well, stellar neighbors can sometimes knock things around, and while they leave things scattered about, it can be for the best, as it is for this planet and perhaps our own planet 9, which are bound up happily in their solar systems. Now, moving a little bit further out in our galaxy, in fact, moving out of our galaxy altogether, we have a case of, well, black holes blowing bubbles. In this particular galaxy, which is named NGC 3079, we are seeing an edge on galaxy and the purple bubble in the center. Those are X-ray detections made by the Chandra X-ray Observatory of a bubble blown in the gas and dust surrounding this galaxy that was blown by material getting accelerated out of the region surrounding the supermassive black hole. Now, there's going to be reports out there that say the black hole is blowing the particles. Black holes don't do that. Black holes can consume things and keep them forever. This is what black holes do. But the surrounding materials around a black hole form a disk with extremely powerful magnetic fields, and this is capable of accelerating particles, creating what we call cosmic rays. And in this case, we are seeing, well, a bubble getting blown by a galaxy. And this is also just further evidence that, yes, cosmic rays that we detect here on Earth are, in some cases, the results of, well, material getting eaten, but not quite making it into the mouth of a black hole. This is the equivalent of a black hole bringing in the material, and the material decides to instead jettison itself along a magnetic field line. Okay, so in our final story of the day, we are going to stay outside of our galaxy and continue looking at the effects of angry black holes. In this case, we have another story brought to us, in this case by the Jet Propulsion Lab, where scientists using the Spitzer Infrared Observatory, another orbiting spacecraft looking out in colors of light that we can't see from the surface of our planet. This spacecraft has been looking at galaxies in the process of merging together. Here we have a spiral galaxy and a small irregular that are merging. Here we have two other disk galaxies in the process of merging in these two different images. And what we're learning, and this is something that is more evidence of a phenomena that we had already suspected was taking place. What we find is large elliptical galaxies are filled with red stars, and red stars are in general either extremely long-lived red dwarf stars or elderly stars such as red supergiants. And all of these red stars, well, because they are essentially old, or evidence that there's nothing blue around and no star forming taking place, we refer to these elliptical galaxies quite often as being red and dead. Now, to get this way, something had to happen that either consumed all of the gas and dust in these galaxies, jettisoned it out of the system, or caused it to all get tied up into, well, a supermassive black hole, into star formation, into something. And what we're starting to piece together is a picture where certain kinds of impacts, certain kinds of mergers, when galaxies of the correct mass ratios coming together with the correct velocities and angular momentum, when these mergers take place, material is driven in to the central supermassive black hole. Some of this material falls in, some of it gets jettisoned along jets, and in general, that accretion disk lights up, and the light pressure of that accretion disk is capable of pushing out other gas and dust in the galaxy. So we're looking at a double factor, where on one hand, we have the material, the gas and dust, is getting triggered into star formation. That will go through a brief interval during the merger process and then end. We also have the remaining gas and dust is getting pushed out by this active galactic nuclei. And we see material getting tied up in that accretion disk, getting jettisoned as jets, and ultimately a lot of it is going to end up in that supermassive black hole. It turns out that star-forming galaxies with active black holes, well, they trigger all that star formation and then they stop forever with no more stars to come. So we now are understanding how galaxy mergers can end the birth of stars in some systems, or at least we're one step closer to fully understanding the process. Now, that was a fast-paced run through today's news. I did get a message just before I went live with this show that I do have an important work-related phone call I'm going to have to make. I will give you a quick roundup and tell you when to come back to ask questions. Later today, we are not going to be airing an episode of Astronomy Cast as we normally would. Instead, Fraser Kane is getting ready to fly off to Costa Rica to go on a tour with Paul Matt Sutter and some of your best friends. Now, this is the kind of trip that you are invited to join us on. In fact, coming in June, there is going to be an all-stars star party out at Joshua Tree National Park in California. You are all invited. Unfortunately, the price tag is kind of high, but if you looked before and went, no, I can't afford that, look again. They have dropped the price on this tour. And I'm hoping that we can get enough signups that this takes place. We need you to sign up. So this will be taking place June 26th through 30th. And as I've mentioned before, we may be witnessing the last generation of Joshua trees to exist in this park. So join me and hug a tree. Yeah. They're pretty. They're awesome. We need to go visit them. And there'll be science and other stuff as well. Now, if June is not the time for you, I will be leading a tour group starting in Tucson, Arizona, ending in Las Vegas, baby. And we will be going through the American Southwest. We will be visiting observatories, seeing some of the most amazing geology in the nation, and of course, kicking back in amazing hotels and telling stories as we travel through the countryside. So join me on one or both of these trips. And know that Fraser is on his way today, so no astronomy cast. In its place, I will be here on CosmoQuest X answering your questions and working on putting together extra bits and bobs for our Twitch channel and our YouTube channel. So join in and let's work on graphics, talk science, and well, just be sciencey together. And then come back tonight at way too late and let's share a rocket launch as SpaceX tests a human-capable capsule on a journey to the International Space Station. And as always, we here at the Daily Space are just one part of CosmoQuest. With the Daily Space, we are here most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. We also return Sundays with Annie Wilson for Sunday Science Hour. Same time, same place. In addition to these regularly scheduled events, we are also here to bring you launches, landings, and other, well, science events as they happen. Give us a follow. Follows are free and let you know whenever we're going live when the science is happening. We are sustained by you. Your subscriptions are what keep us going. Thank you all so much for your subscriptions and donations that make this show possible. We are a production of the Planetary Science Institute working in collaboration with Youngstown State University. And with that, I am going to have to end things early so I can make a phone call. I am now looking for the window that will, thank you, RefsMatt, thank you so much. I am now looking for the button that will let me run the end credits. And then we are going to do a raid. I think Oh Bother is live. I'm going to see who else may be out there. As always, feel free to make suggestions. We are part of the Knowledge Fellowship, and we are here to put knowledge into all your brains. So join us live, and with the Knowledge Fellowship, there is always content to help you learn. So we are going to be rating Maker. Wait, he's currently hosting us. That doesn't work. I am confused. I think my back end is behind. So confused. Let's see. Oh Bother is live. Okay, so we're going to raid Oh Bother. So wherever you are in the world, have a fabulous morning, evening, or afternoon. And if the weather allows, get out and look up. Bye-bye.